All right, guys, we're ready. All right. So next time we meet on Friday, we're gonna have a quiz, guys. Make sure that you know how to do this. Like, what's this quiz gonna be about? It's gonna be about everything we've done so far. Pretty much with composite argument properties, like something like this. And well, don't worry, we're gonna give you guys plenty of practice. We already got more practice today and leading up to Friday. So check it out. So we have angle x is in quadrant 1 and sine x is 2/5. So here's quadrant 1. Here's angle x. Here's my right angle. And remember that SOHCAHTOA. And remember that sine is 2/5. Sine is opposite over hypotenuse, so 2, 5. So then we can figure out this distance just by doing Pythagorean theorem. So remember, we already have the hypotenuse, so a squared plus b squared equals c squared. So you're going to have to subtract because we already got the hypotenuse. 5 squared minus 2 squared. 5 squared is 25. 2 squared is 4. 25 minus 4 is 21. It does not break down. Leave it as square root of 21. Are we still okay? And then I'm going to go ahead and do this one in blue, guys. That is quadrant between 180 and 270. That is quadrant 3. The hypotenuse is never negative. The hypotenuse is like a radius. So let's exaggerate quadrant 3. And opposite of our hypotenuse, so negative 1, 3. So again, I want this distance here. That's going to be the square root of 3 squared minus negative 1 squared. 3 squared is 9. Negative 1 squared is 1. 9 minus 1 is 8. The square root of 8 breaks down. 4 times 2. So that's going to be 2 square root of 2. Because I am in quadrant 3, it has to be negative. Are we okay with that? We can at least do that, right? Okay. Next, cosine x minus y. Cosine x minus y, I'm going to write it right here. Cosine x minus y is cosine x, cosine y, plus sine x, sine y. And now all we're doing is grab the numbers from your two right triangles, guys. Cosine x. I think that was given. Nope, it wasn't. Cosine x is adjacent over hypotenuse. Square root of 21 over 5. And I'll zoom in right now. Cosine y, this is angle y right here. Negative 2 square root of 2 over 3. Is anyone freaking out? Okay. Plus sine x. Sine x was given. That was 2/5. Well, I guess you don't need to go up there. You can just look at the triangle. And then sine y is a negative 1/3. So let's see what this is. Negative 2 square root of 21 times 2. 42 over 15. Minus 2 over 15. Positive times the negative. So now we just combine because the denominators are the same. Negative 2 square root of 42 minus 2 all over 15. Can we do that? We can do that, right, guys? Okay. All right. Let's derive these. Of course, like every time, guys. I don't want to be that teacher just give you the formulas. I want to make sure that you know that all these formulas come from somewhere. So it says, how do we derive sine 2a? So we got to know one formula. Do you know what sine x plus y is? Yeah, that's sine x cosine y plus cosine x sine y. So here's how we're going to figure out what sine 2a is. We're going to write sine a plus a. Do you agree that's sine 2a? Yeah, that's sine 2a, guys. A plus a. And I'm going to use this formula right here. This is like an A. That's like an A, see? So we're going to write it like this. Sine A cosine A plus cosine A sine A. Sine A times cosine A is the same as cosine A times sine A. Does that make sense to you guys? How many of these do you see? Not everyone at the same time. How many? Yeah, 2 of them. You can say it loud and proud. 2 of them, guys. 2 sine A, cosine A. Sorry. And there it is. That's it. That's a formula. How do you feel? Not bad, right? Pretty straightforward. Okay. So that's one of them. What about cosine 2A? And I know I was feeling kind of funny, but now that I read it, it's just lame. What about cosine 2A? That's what I was. You thinking about cosine 2A and how we're going to beat up? Yeah. The calculus class, we're probably going to have 100% qualify. It looks like we're on that route. Anyways, let's get back to this topic. Cosine 2A. Well, do you remember how to get cosine x plus y? That's how we're going to get it. That's a plus in the middle, by the way. Plus. Cosine x, cosine y, plus or minus? Minus. Sine x, sine y. So that's exactly how we're going to do it, guys. Here we go. Ready? Cosine A plus A. That's cosine 2A. I'm going to use this formula right here. Cosine A minus sine A, sine A. What's cosine times cosine? No, so say the square first. Cosine square A minus sine square A. There it is. That's another formula, guys. Cosine 2A. There's more. Can cosine 2A be defined with different expressions? Heck yeah, it can. Remember, guys, your side note. Remember your Valentine's formula that cosine squared A plus sine squared A equals 1. Remember that. That one's always true. Because that's true, I can replace this cosine squared with... Oh, man. I can replace the cosine squared with what? 1 minus sine squared. Minus sine squared. That's that one. And then this is just replaced. In case I see some of you looking at me like you don't know what I'm talking about. If you move the sine squared to the right, cosine squared A equals 1 minus sine squared. And we've talked about that a few times. So now you can just drop the parentheses. So look, cosine 2A is equal to 1 minus sine squared A minus sine squared A. I have 2 of those. 1 minus 2 sine squared A. There's my answer. That's another formula. One more different one. I'm going to start from here again. Cosine 2A equals cosine squared A minus sine squared A. I could have also said, I could have moved this to the right. I could have said sine squared A is equal to 1 minus cosine squared A. So that means I could have replaced sine squared A with 1 minus cosine squared A. So I can say cosine 2A equals cosine squared A minus, parenthesis, 1 minus cosine squared A. And then distribute the negative. So don't worry, guys, we're almost done. Cosine squared A minus 1 plus cosine squared A. So here's what you get. You got 2 of those there. So I can say that cosine 2A is nothing more than 2 cosine squared A minus 1. How do we feel? We just derived 3 formulas, guys. Actually 4. 1, 2, 3, 4. Yeah, we derived 4 formulas. Don't worry, we're going to show you all the formulas right now. Last one. I want to derive tan 2A. Do you guys remember how to derive tan of x plus y? Yeah, hopefully you remember. That's tan x plus tan y over 1 minus tan x tan y. So that's the formula we're going to use, guys. I'm going to plug in an a and a for both of those x and y. So I'm going to write tan of a plus a, because that's what tan 2a is, right? Tan a plus tan a over 1 minus tan a tan a. And my laptop's a little slow. I don't know, maybe someone hacked it because it's going really slow. Like the delay is really crazy. 2 tan a over 1 minus tan squared a. See? That's my formula. How do we feel? All right, if you go to the next page, you derived all those formulas by hand. All of them come from somewhere, guys. I don't want to be that teacher that just gives you these formulas and then just say, all right, use them. I wanted to make sure that you guys know where they all come from. Are we clear? All right, let's do example 2 here. It says if cosine x equals 0.3, find the exact value of cosine 2x. Check your answer numerically by finding the value of x, doubling it, and finding the cosine of the resulting argument. Okay, here's what they're telling us to do. They want cosine 2x. I'm going to come up here, and there's only one that uses cosine x. Look at this one right here. I'll write it for you in terms of x. Cosine 2x equals 2 cosine squared x minus 1. What does that mean? It means this, 2 cosine x, and that's being squared minus 1. That's what it means. The squared next to the s. Are we okay? And look, by the way, this is coming from a UH question. Well, the first half. The second half is not. Here's how that kid did it. And then they had A, B, C, D on the side, right? This is before you could use the calculator. Here's how he did it. He goes 2, and then cosine x was 0.3. 0.3 squared minus 1. And then he goes 2, and then 0.3 squared. What do you think that is? 3 squared is 9. What do you think 0.3 squared is? 0.9 or 0.09? 0.09. In case you're wondering how do you do that without a calculator like this, guys? 0.3 times 0.3. I go 3 times 3 is 9, and then I just count. I count from here. 1, 2. So you just do 2 spaces. 1, 2, dot, 0. See? Go to sleep earlier, Miss America. All right. Minus 1. Double the 0.09. When you double the 0.09, that is 0.18 minus 1. 0.18 minus 1. Well, if that was 18 and that was 100, that would be, the difference would be 82. So this is a negative 0.82. Do you see how we did it? Okay. Let's see. I'm not fake, guys. Let's see if we can do this, and I bet you it'll be the exact number, negative 0.82. So watch. Take your calculator. And here's the fun part right here, I think. Remember how they told me that cosine x was 0.3? Is that what they told me? Yeah, it says check your answer numerically by finding the value of x, doubling it, and find the value. Okay, so that's what I'm going to do. Oh, look, there it is. I'm going to clear it so you guys pretend you guys didn't see that because we did it at the 6th period. All right, cosine x is 0.3. So arc cosine of 0.3, close it, enter. This is my angle. I'm going to call that A. Store alpha A. So check it out. Here's what they're telling me. That if I go cosine, if I go cosine of A, it's going to give me 0.3, right? So cosine of A, I better get 0.3. And you do. So now look at this. Cosine of 2A. Didn't we just calculate this right now? And didn't we get a negative 0.82? Well, look at this. Isn't that awesome? You guys don't think that's awesome? You future engineers, look, you're messing with signals. You're compressing signals, you're stretching signals. I think it's awesome, guys. Make sure you guys know what's happening here. So I think it's awesome. There it is. We verified it. Cool. Yay or nay? All right. Here we go. These are the type of questions that you'll probably see. You might see one of these. I don't know. I haven't typed out the quiz yet. It says, given cosecant, example 3, given cosecant x equals -6 with 270 to 360, find cosine 2x. All right. Cosecant -6, that means that sine x was a -1/6. I'm going to use the answer that only uses sine. So you come up here and you look and you're like, well, this answer only uses sine. So that's the only one you're going to use. So you're going to come back and then you're going to write cosine 2x has to be 1 minus 2 sine squared of x. I already have sine x, guys. 1 minus 2, -1/6 squared. 1 minus 2, and I'm going to square this. -1 times a -1 is a 1. 6 times 6 is 36. 2 goes into 36 18 times. 1 minus 1 over 18. Chav, I need a calculator. No, you don't. Turn that 1 into 18 over 18 minus 1 over 18. What's 18 minus 1? There it is. How do we feel? All right, we're almost done, guys. 2 more examples, and then we'll set you guys loose with the delta activity. Write an equation expressing cosine 10x in terms of sine 5x. Okay, well, that means we're using this formula again. Just recognize that 5x and that 10x is double of 5x. Do you guys see that? So we can write it like this. Cosine 2 times 5x, that's your 10x, is equal to 1 minus 2 sine squared, that says x, of 5x. Done. That's it. That's it. I guess if you want to see 10x instead of 2 times 5x, cosine 10x equals 1 minus 2 sine squared of 5x. How do we feel, guys? Nothing crazy, right? Nothing crazy. Write the equation in example 4 directly from the composite argument property. Oh, okay. That's what so that means cosine A plus B. So here we go. Cosine 5x plus 5x. I'm just expanding this. Cosine 5x minus sine 5x sine 5x. Let's see what we got. Cosine times cosine? Yeah, cosine squared 5x. Sine times sine? Sine squared 5x. I don't have the answer just yet. I want it to look like the answer on the top. I'll make a side note. My side note is cosine squared 5x plus sine squared of 5x is equal to 1. So I'm going to replace cosine squared 5x with 1 minus sine squared 5x. So here we go. 1 minus sine squared 5x minus sine squared 5x. I have 2 of those. So cosine 10x is nothing more than 1 minus 2 sine squared of 5x. That's exactly what I have up there. If you want to put the 5x in parentheses, you can. And there it is, guys. You have been exposed. All you need now is practice. Yay or nay? All right, guys, practice. There's some delta math. And that's it. I'll make sure to take care of it today. And that's it. We're done, guys. Good job.